Hi, and welcome to this first video in the series on data interpretation presentation, which is from the Year 1 Stats course. And in this video, we're going to have a look at outliers and anomalies, and then in subsequent videos get on to the box and whiskey cumulative frequency histograms, frequency polygons. But as I said, this video, we're just going to be having a look at outliers and anomalies, and hopefully clear up a couple of myths, because most people tend to view those two things as basically the same. And as we're going to see in this video, there is an important mathematical statistical difference between the two things. So let's kick off with an outlier. So an outlier is an observation that lies outside the overall pattern of a distribution. Now I know that as a definition doesn't give you a lot of clues as to what's going on, but what you're going to get is a definition to work to. And you're always going to be given this, you're not going to have to come up with these yourself. And one definition might be that, for example. Now, what we're looking at there, it says underneath the blue shaded bit, we've got Q3, which is the upper quartile, plus, and we've got Q3 minus Q1, which is the interquartile range. So it's a measure of how far above the upper quartile this piece of data actually is. And it's a multiple of the upper quartile. And that value for K there might change depending on what you're being given. And that would be for a piece of data that's kind of higher than the overall pattern of the distribution. And then the bit underneath, this bit down here, is the same thing but working below the lower quartile. So Q1, the lower quartile, take off a multiple of the interquartile range. And so anything that's above that value or below that value, it's still a genuine observation within our data set, but it's statistically kind of different to the rest of the data. It's outside the overall pattern of the distribution. So that's a definition that works off of medians and interquartiles. The alternative you might get might be something like this, which is the mean, that plus or minus a certain number of standard deviations. And that one tends to be used a lot more, and you'll see that kind of definition happening a lot more when we talk about normal distributions and the such like in year 2. So the first definition is based around medians and the accompanying measure of spread, which is interquartile range. The second definition is based around mean and its accompanying measure of spread, which is standard deviation. Right, that's enough chat. These things always make a lot more sense when you actually see what's going on. So let's have a look at an example. And what I've done is whip some data from the large data set on weather data. So I've taken it from Camborne weather data 1987, maximum gust speeds, and we've got there a definition that we're given, which is the outlier is a value that lies 1.5 times the IQR above upper quartile, or 1.5 times IQR below the lower quartile. So first we're going to do is figure out where the quartiles are, and then from there work out where our outliers are going to be. Right, so there's our data set, and clearly the first thing we need to do if we're dealing with quartiles and medians and all the rest of it is reorder it. So let's just quickly do that. There it is. And first thing to note is how many pieces of data we're dealing with. Well, we had 31 in October, but we've got 2 there that are not applicable, so negligible, so we're working with 29 values. So we now need to figure out where the quartiles are. Now, the rules for finding where your quartiles are located from discrete are different compared to grouped, and I'm going to go with the definitions that are given in the textbook for Edexcel, which is these. So the lower quartile for discrete data, just do n divided by 4. If that's a whole number, then go halfway, but if it's not a whole number, then round up. And the same thing applies for the upper quartile, but instead of just divided by 4, you can see here it's 3/4. So those are the definitions we're going to use. So let's go back now and apply that to our data set. So we've got 29 pieces of data, divide by 4, 7.25. It's not a whole number, so what we're going to do is round up. I know it seems weird to be doing 0.25 rounding up, but that's what the rules say. And so that means our lower quartile is the 8th piece of data. So let's just go through and pick that one out. There it is. And for the same for Q3, our upper quartile, 3/4 of 29 is 21.75. And so that makes Q3 our 22nd piece of data. There it is. So Q3 is 37. So there's our upper and lower quartiles. So on we go. And let's start now thinking about our definition of what an outlier is. 1.5 times the interquartile range. So interquartile range is 14. So if we start off by looking at our outliers, they're going to be below the low quartile. So we're going to take our lower quartile, which is 23, and take off 1.5 lots of 14. So let's do that, and we get an answer of 2. So anything with a maximum gust below 2 knots is going to be an outlier. And as you can see, we haven't got any of those. And let's have a look at the ones that are above a certain value. So this time we want to use the upper quartile, the 37, plus 1.5 times 14, which is 58. So what that does is gives us 59, which we're now defining as being an outlier. And as it turns out, if you know your large data set and you know about October 1987, you'll know that that maximum gust speed was the 16th of October, which when the big storm hit. Now, interestingly enough, if you look back at this data set, if we have a look at the days around that, or in close to it, we've got 53, 59, 55, 54. So on the days like sort of 15th, 16th, 17th, 18th of October, we did get strong winds, but bear in mind those were not average wind speeds for the day. Those were just maximum gusts. So it was actually just kind of the 16th when the big storm actually hit, where we had stronger gusts and also higher average wind speeds as well. So there we go. So that's that bit done. Let's now have a look at the same data, but let's do the same with mean and standard deviation. And this is, like I said, mainly you can get your mean and standard deviations off the calculator, but if they're giving you summary data like this, so expect you to use the formulas, which you pull out of the formula booklet. Well, you don't need the one for the mean, it's just add them all up, divided by how many you've got, which is 949 divided by 29. But for the standard deviation, that's the one you pull out of the formula booklet, and you just plop your numbers into there. There we go. And so we've got our mean and standard deviation. Now let's get a definition for what we're going to use as an outlier. And so we're going to say our outlier is plus or minus 2 standard deviations away from the mean. So here we go. Our outliers are beyond 32.7 plus or minus 2 lots of the standard deviation. So at the upper end of our range, that's going to give us a value of 57.68. And at the lower end, for our week of wind gusts, we've got 7.77. So again, as it turns out in that particular definition, that also gives us 59 as our outlier. So there you go. Outliers are a genuine piece of data, but just are outside the normal pattern of the distribution. Let's go and have a look at what an anomaly is. As I said, outliers are legitimate observations, and so still need to be included in our data set, because we can't just get rid of large or small values just because they look a bit different. They are genuine data values. However, you might get some values that may result in errors of measuring or record, or may have come from the result of errors of measuring or recording. And these are the ones that are the anomalies. So outliers you keep in your data set when you're doing your calculations. Anomalies are the ones you get rid of, and you get rid of them by the process of what's called cleaning the data. So what I've done is, there's our data again from Camborne in 1987, but what I've done now is inserted an anomaly. And if you have a bit of a look through, hopefully you'll be able to spot it. And there it is. So we've got a value there that is seems very, very odd. It might be, like I say, we just had a storm. So what we do, we have a look at other data evidence around that, have a little look at what's going on. And there's nothing to suggest an exceptional weather event on that date, October 25th. So it's probably realistic and correct to assume that we've got a transcription error. So that should have been 19 rather than 91. Somebody's written down the digits just the wrong way around, and therefore it is valid to remove it from the data set. So outliers, legitimate observations, and they need to be included. And we've got our definitions for what makes an outlier, whereas anomalies are the ones that we can clean the data and get rid of them because they're a result generally of measuring or recording errors. And there we go.